All right. So last week, or no, it's not last week, it's this week. Earlier this week, we looked at last week you started trigonometry and you did all the trigonometry concerning right angle triangle. So you did Pythagoras theorem, sine, and you did the trig ratios, SOHCAHTOA, sine equal opposite over hypotenuse, cosine equal adjacent over hypotenuse, and tangent equals to opposite over adjacent. On Thursday, we went a step further, and we did trigonometry that concerns general triangle. So it concerns any triangle and not just a right angle triangle. So some of the basic things, the two main rules, I don't know if we can call them rules. They are rules that we looked at were the sine rule and the cosine rule that you can use to find the length of sides or the size of angles in a triangle. So just writing them over. Sorry. So saying I have this triangle here. This is my triangle, and each triangle has three angles, right? And the three angles in a triangle equal to what? That's a question.
180 degrees.
Good. Angles in a triangle equal 180 degrees. Now, this is not a part of the rule, but I'm putting it there because I want you to keep understanding that when you're working, even though we're just doing sine and cosine rule here, so when you are working questions, you may have to pull information from other knowledge areas like this. And this is a triangle. So angles in a triangle equal 180. So I'm just reinforcing that for you. Yes. So let's go ahead. So what we had said in relation to the sine and the cosine rule is if you have a triangle with each angle with three angles, I'm going to just arbitrarily label these angles A, B, C. And we made the point in the last class that I could have labeled any one of these A, B, C. It doesn't matter what order, right? What is important is that we realize something about A, B, C. When it comes to the sine and the cosine rule, we are interested in the side opposite to it. So the side opposite to angle A, which I have put in here, I'm going to just recall that little a, common letter A, yes? The side that is opposite to angle B, I have that in yellow, can call that little b. And the side opposite to angle C, I have that in blue, I can call that little c. So in effect, the sine and the cosine rule has to do with relationships between the angles and their opposite side, right? So that's what we have here. So our sine rule says the side over the sine of the opposite angle is equal to the next side over the sine of the other opposite angle. And because there are three angles in a triangle, it holds true for any of them. So what that means is that if you were to take this side over the sine of the opposite angle, it is going to be equal to any of the other sides over the sine of the opposite angle. Any of them, any two of these you can put together and they are equal. A over sine A is equal to B over sine B. That same A over sine A is equal to C over sine C. They're all equal. The ratios are equal. So that's what the sine rule says. The cosine rule says a squared and that's common a, so it refers to the side, is equal to b squared plus c squared minus 2bc times the cosine of a. And we made the point that even though it says a here and we have a as being this particular side over here, this formula can be written for any of the sides, right? So in essence, a could be any of these sides here. But because we have B, C, and A here, I'm just going to rewrite the formula for side B, and all it would be B squared is equal to the sum of the squared of the other sides, which is A and C, minus 2 times the other sides, 2 times AC, and multiplied by cosine B. And if I write this formula for the other side, which is C squared, it is equal to A squared plus B squared minus 2 times A times B times the cosine of C. I made the point last week, well, in our last class, that whatever side, can't find my cursor. Okay. I made the point the last time that whatever side you are finding when it comes to the cosine rule, that the corresponding angle is what you have the cosine of here. So whatever you have on the outside, that corresponding angle is what you're finding with, is what you have with cosine C here. All right, just to have you understand the question a little bit more, the formula a little bit more, and then you will have both sides, the length of both sides in play on the inside. So you have them being squared and added here and being multiplied both by 2, well, 2 times both of those sides here, all right? So these are the sides, and these are the rules, the sine rule and the cosine rule, and this is what this triangle here is a representation of what those letters in the sine rule and cosine rule means, all right? So for our last class, we did a couple questions on sine rule and a couple questions on cosine rule. And so we are going to just continue in that same vein now. The last time we spoke about sorry, I'm just pulling up the document that we're going to be working from. Yeah. So the last time we spoke, I had told you that this document that Sir had sent in the group, that it has questions on it, and that those questions you should attempt to work leading up to our class today. So what we're going to do, we're going to be working a couple questions from this. I'm going to give you about 15 minutes to work about 10 minutes to work about 4 of these questions. And then we will go through them together. Once we're comfortable that everybody understands the sine and cosine rule, we have one last question and then we move on to bearing. So let me just, and you're seeing this on your screen, yes? Are you seeing the questions on your screen?
Yes, miss.
Page 12 and page 11. Did anyone attempt any of these? No? All right, so we're going to be doing questions 1 to 4 here. And you're trying to find the missing angle. When you're ready for the other 2, I can just scroll down. But we're doing just the first 4, just as a practice. So we're finding for each of them the missing angle, theta. That's what you're trying to find. So I'm giving you 10 minutes to work these 4 questions, and I will halfway through, I will just shift down so that you're able to see the other 2 questions. So go ahead and start working on those now. At least take them off. Everybody gone? So I'm going to just move it down. You should have figured by now that these are the 2 that that was on the screen, that you would need to use the sine rule for them, because as you can see, you have 2 sides. 10.3, that's the opposite angle, 85 degree, and 8.1, that's the opposite angle, theta. So you could use the sine rule to solve this, and it's the same thing for B, and it's the same thing for the other 2 that we are going to be doing, which is C and D. So I'll give you another 5 minutes to go through C and D, and then we'll work through them together, and then we move on to some cosine rule examples before, yeah.
Miss, I having a little challenge.
Okay.
I don't have the digital calculator. That means I have to
Oh, the
use.
scientific calculator. Do you have your phone, or is it that you're using your phone?
Yeah, I have a phone. I have my phone, so I
Okay.
can use the phone.
Yeah, you can use your phone. So usually, for your phone, it would give you the regular calculator first, and there usually is an option. I'm not. Let me just pause this recording. All right. So the first triangle looked something like what's happening? So you had 85 degrees here. This was an unknown. I'm putting X. So they have theta, but I'm just putting X because my theta not going to hold. This is 10.3 centimeters, and this is 8.1 centimeters here. And you're asked to find the unknown angle. So I was saying earlier that it's a sine rule that you're going to have to use here, because we spoke about in the last class that when you have say, for example, 2 angles on one side, or 2 sides on one angle, you use the sine rule, and I can show you why. So let's just write down the sine rule. A, that's a side, over the sine of the angle, is equal to B over the sine of angle B, right? So if you have any 3 of these, you can solve for the 4th one that you don't know. So you would at least need, if you're trying to find an angle, as what we are doing now, you need to have both sides, 2 sides, as well as an opposite angle, right? And we do have that. If you wanted to solve for a side, you need to have both angles and at least one of the sides, right? So we can go ahead and solve and solve for this angle X using using the sine rule. So the first thing I like to do is just to identify what is what. So this unknown angle here, this is the opposite side, right? So if I call this angle big A, then this would be my little a side over here, right? So this would be for here. And if I call this angle big B, then the opposite side, which is this, would be my little b. So I can then go ahead and substitute in the formula. So small a is 8.1 over the sine of A, because we don't know what it is. That's what we're trying to find. If you choose to put the sign of X here, that's completely fine as well, as long as you have the corresponding proper angle in the numerator. It doesn't matter if you put X or A. I'm just putting A just to keep true to the formula as I had it written up here. B, small b is 10.3. So we have 10.3 over the corresponding angle is 85. So that's a sine of 85. We then go ahead and cross multiply. So I like to have the one that I'm trying to find on the left side. So I'm going to put sine A times 10.3 equals to sine 85 times 8.1 because you cross multiplying. So from here, so you can either work out this portion first and then get a number for it and then carry over this 10, but I'm going to just carry it over just straight off the bat, and then we work out each part. So I'm going to carry over this 10 over across the equal sign so I can have sine A by itself because I'm trying to find A. So because this 10.3 is being multiplied over on this side of the equal sign, when I take it over, what's going to happen to it?
It becomes divide.
Divide. Thank you very much. So we're going to have sine A is equal to, and I'm keeping this because this was over here before. So we have sine 85 times 8.1 all over this 10.3 here. So we can go ahead and plug in those values in the calculator. What is sine 85? Nobody giving me an answer? Anybody have a calculator can work it out?
Zero 0.996.
Right, and then multiply that by 0.8 by 8.1.
8.069.
8.069, thank you. 8.069, and then that is divided, is all over 10.3. So you can now divide that by 10.3. Tell me what you get.
0.783.
So sine A equals to
783.
0.783. Thank you very much. So the next step now is to get rid of this sign. So we would carry it over. So we would have A, which is the angle we're looking for, equals the inverse of sine. Because you carry it over the equal sign, it becomes the inverse, 0.783. And if you plug that in a calculator, what do you get?
51.536.
All right, so I'm going to have 51.57 degrees. So that is what your angle measures. So that is our first question. Any questions so far? All right, moving on to our second triangle, because we have quite a bit to work.
Please, sorry.
So why you wait till me rub it off, then you talk to me?
Right. All right.
Talk to me same way, let me see if I can answer you. Who was that? Hello?
Misha.
Okay, what you saying, Misha?
No, the 0.783. That part basically A is equal to sine. I didn't get that part.
Fine, in all right. So we had, so let me just go back up. We would have had sine B equal to 0.783, yes? So if you remember,
Yep.
the B represented the angle, yes?
Angle.
And this is the angle that we wanted to find, right? But we have the sine beside the B, and we need to get rid of it. Now, if you had if you had, say for example, you had 3b equals 0.783, how would you get rid of this 3?
Um,
3b means 3 times b. I want b by itself.
Times it, miss?
Huh?
Would I times it?
Well, it is being multiplied, but you would divide both sides by 3 over here, so
3.
right? And
Okay,
it's the same thing where we say we're going to carry 3 across the equal sign over here. So, and when you carry it across, it becomes a divide. Yes?
Okay.
Remember that?
Yes,
Now that is when you have a number. Now with the sine and the cosine and the tangent, when you carry it across the equal sign, it becomes its inverse. So inverse is what we call like the opposite of the sign, right? So it will be b equal, when you carry this sign across the equal sign, it becomes the inverse.
Inverse, yeah.
Which we denote by saying sine to the negative 1, 0.783. Right? So you won't see sine inverse as a button on your calculator though. You'd have to press a shift and then press sine. Or if your calculator has a second function, you have to press second function, then you press sine, and you will see the sine inverse come up on the screen.
Okay.
But sine inverse is just or if it were cosine inverse or tan inverse, that's what you get when you carry it across the equal sign. It's the opposite of sine. Just like how the opposite of multiplication is division and the opposite of addition is subtraction, in a similar way. That's what it is. Carrying it across the equal sign, it becomes a sine inverse. That answers your question?
Yes, miss.
Yes? All right, clear?
So it would remain as it is. That would be the final answer.
The final answer
0
would
points.
be no. So you would actually, just like when you can touch sine on your calculator, you would put sine inverse in your calculator 0.73, and you would get a number, and that number would be 51.57, which would be our answer. Follow?
Okay. Yes, miss.
Yeah. So the sine inverse 0.73, there's one more step. You have to put that in your calculator to get the answer.
Okay. Okay.
All right. So number 2 now, 79, and then we have one side 2.9 and then 3.6 here. So we're looking to find this angle here, which is x, and we can see x has an opposite side, and then this angle 79 also has an opposite side. So I'm going to go ahead and call this angle here A, which is this 79, which means that the opposite side is small a. This angle x that we're trying to find is B, which means that our opposite side is small b, and then we can go ahead and apply the sine rule. All right, so small a is 2.9 over the angle. We don't know the angle. I'm going to put B. You can put X if you want. That's also perfectly fine. Did I do something wrong just now? Sure, foolishness, no. But tell me the foolishness, 2.9. All right, let's go back for the thing. It was right, but it's not sine A. I had called this B on the diagram, so I just want to remain consistent. So 3.6. 3.6, and then that will be sine 79. B, small b, we said that was, I feel like I'm doing foolishness. I write something, I don't know if I'm write something wrong. This is small b, not A. So small b would be 2.9 over the angle. That is what we're trying to find, right? So we go ahead and we cross multiply that by that. And we would get for this one sine B times 3.6 equals to sine 79 times 2.9. So again, I'm going to just carry over this 3.6 to have sine B by itself, and then I start working out. So sine 79 times 2.9, and that is all over this 3.6 that I'm going to be carrying over, all right? So we can do the calculator maths now. What the top part give us? Sine 79 times 2.9 give us what?
2.84. So you'll have 0.981 times 2.9,
Mm-hmm.
which is equal to 2.846 over 3.6, which is equal to 0.79. Sine B
Okay,
equals
equals to
0.79.
0.79. All right, that's what I have. 0.7907. So all of this up here, so if you multiply the top and then divide it by 3.6, you get 0.7907. So now we are going to have to carry the sign across so that we can have B by itself. So if we carry the sign across the equal sign, it becomes an inverse. Yes, that's what we were talking about just now. So the B, which is the angle, is going to equal to sine inverse 0.7907. So that B is equal to, so you have to plug this in the
52.19.
calculator, and you get
52.19.
all right, 52
Hold
point,
up.
all right, I get 0.25, but it doesn't matter.
Okay.
0.19 degrees because it's an angle.
Okay.
All right. So that's our second one. Any questions? All right. So I'm only going to do one more of these sine questions and then we'll move on to the cosine questions. So the last one is going to be, we're going to labor on the last one somewhat. So I want to make sure we have enough time to do that laboring. So just the third question. To give us enough practice. All right, so you have 4.2 here, 5.1. You have an angle that you don't know over here, and then you have 66 over here. So again, we can look at this diagram and try to figure out some information. We can call this angle A. And I want you to note that I arbitrarily call an angle anything, right? It doesn't matter if it's A or B. It will work in the formula just as well, all right? So I can call this angle A. So that means that the opposite side would be small a. If I call this angle B, this opposite side over here would be small b. So I'm hoping that you all, let me just put the arrows in just the same. That's the opposite side. And that's the opposite side right there. So I can go ahead and use my sine rule A, which is the side, over the sine of the opposite angle is equal to the next side over the sine of that opposite angle. All right. So let's just substitute these now, A's and B's in the formula. So this A is 5.1 here over sine of, why I keep
Excuse
writing this
me,
wrong? Now the foolishness.
Miss.
Yes.
The top where you have the A over sine A equal B over sine B, that is the rule that we should follow, whereas it we won't get confused to know how to they kind of interject the figures. That is how we should always follow that top rule where you have
So
the
you're talking
figures.
about this that I'm boxing
That's
up.
right. Yes, miss.
So this
We
is
have to
called
always put that down. Yeah, we have to
this
always
Yes, this is
Write
called
that
the
down.
sine rule,
Rule,
right?
yes.
This is called the sine rule. Now, as we are doing it now, it's easy, because all of these triangles are using the sine rule. But when you
Yeah.
go into an exam and you get a triangle, you are going to have to decide if it's a sine rule you're going to use or if it is a cosine rule you're going to use. And how you do that, you have to just look at the information you get and see which rule you can work. As a rule of thumb, as we always say, if you have two sides and an angle, or two angles and a side,
Yes, yes.
are you trying to find a missing angle or a missing side, you use the sine rule.
This is the sine rule.
You
Okay.
use the sine rule. I can, but you usually you're just going to have to look at the triangle, just like how I go through and say, okay, I have this angle, I have that angle, and this side and that side, and then I have to figure out now. Well, for this question, you don't have to figure it out, but you use the sine rule. The last question that we're going to do, you're going to see where you are going to have to do the work to figure out if you're going to use the sine rule or the cosine rule. But for now, you're just getting some practice on using the sine rule and the cosine rule separate. All right?
Okay. Okay. Thank you, Miss.
No problem. So sine A, the angle A,
Okay. Thanks.
yeah, the angle A, that's what we're trying to find. The side, second side, side B is 5.1 over this angle, 66. So we have sine of 66. So we can go ahead, cross multiply, and we will have a sine A multiplied by 5.1 equals to sine 66 multiplied by 4.2. I'm going to carry over this 55, this 5.1, sorry, so I can have sine A by itself. So sine A is equal to sine 66 times 4.2 all over 5.1. So now this is just a calculator work. What do we get when we work out this in the calculator? Anybody?
3 point.
Hmm? Nobody know work it out? Sean, I think it's Sean have the calculator working out. I got 0.7523.
1.
So I don't know if that's what you got, Shana.
I got 0.71.
All right, that's fine. That's fine. Same.
Yeah.
It just depends on how much you run off sine 66. So that's fine. So the next thing now is to get A by itself, which means that you're carrying sine over here. It becomes the sine inverse 0.7523. And if
Because
you plug that in your calculator, you get
45.23
45.
or 45.23.
Okay. I don't check it, so I trust in that is what it is. So 45.23 degrees, because it's an angle, don't forget that. And that is your answer. So there goes your practice for your sine rule. So these are just three triangles. And as I said, we are working our way up to a question that uses sine rule and cosine rule, where you have to figure out what to do, which is more an exam type question. So let's go ahead and do some of the cosine rule questions before we get to that last question. All right. So so just remember the cosine rule. I'm going to just write it back here before I move over the questions. Cosine rule is a squared equals to b squared plus c squared minus 2a, no, that's not true, 2b
Worry, the final one.
c times cosine of A, the angle A. All right. So this is your cosine rule. We had said it at the beginning of the class, but I'm just rewriting it. This is your cosine rule that you're going to use to solve the questions that are to come. So we're going to do the first three. All right. So let's go. I think page 12, exercise 2. All right. So these are I think. No, these are sine. All right, here we go. So we're finding these. Just do the first three for me, please. I'll give you about 8 or so minutes to do the first three, and then we work those out. If you want to take down more of them so you can practice, if you want to take down the rest, you can practice. But you should have this document in the group. So just do the first three, please. I'll give you 8 minutes. And I'm going to come back. I'm going to tell you who I'm going to ask. I'm going to ask, so Shauna has been helping me. Misha, you can select one of them to try and do. You don't have to be correct. You don't have to be perfect. I just want to know where you are at. Giovanni, you will do one for me as well. And Amoya, you will attempt one for me as well. All right? So everybody need to try them, but then those 3 persons will tell me, how they fared when they attempted it. You don't have to be right. You don't have to be complete. I just want you to attempt it so I know where you are. All right? Next 8 minutes. I'll come back. Is volunteering. I'm here speaking to myself. Do I have to call on someone? Who attempted it? Who attempted any of the questions? Because you must have attempted something.
Miss, I attempting it, but I'm not sure.
What was that?
I was saying that I attempted it, but I'm not sure.
You're not sure?
I'm not sure.
If you did sure, you wouldn't be at the class. You would have maths already if you did sure, so you don't need for sure. Just let me know what you have. Tell me how you are. Did you get an answer? Misha, did you get an answer?
No, Miss, I still writing out the formula. Same
Just
thing.
like family you there? Anybody else?
Yeah.
How about Giovanni? Did you attempt it? Giovanni? Okay. Everybody not answering me. All right.
I download the app of the scientific calculator,
Mm-hmm.
but it's like each time I press, it's just not. I don't know. It's not responding because I have it up and everything, and it download, but it's like each time I'm pressing the digits,
Mm-hmm.
because I see the cosine, the sine, the tan, the cosine, the tongue, everything. I see all the signs and them come up as I have it up, but for some reason when I'm pressing the digits and to press the equal sign, it does not give me, it not showing me anything. The answer is just not coming up.
Okay. All right. Well, I'd have to see it to work it to know what it is. So, but I can't do
Yeah,
that. I can't do that
yeah, I
now.
understand.
So let's
Yes,
just go
I
through this one question. So we're going to work this one question now because the question says that you ought to find the unknown angles. So all the unknown angles. So as you can see here, you have two angles that you don't know, and you have one side that you don't know. So the question says find all the unknown angles and the unknown sides. So what I'm going to do, I'm going to just label these angles and sides just so that we can track them, keep track of them. So we're going to call this one that we know, we're going to call that A. We can call this one over the left here B and call this one C. So we just label them just so that we can track them. Having done that, now, this is information we have. If we look across from here, we see our small a. Don't know what causes that to happen, you know. Let me just erase it because it take over all of me. All right, sorry about that. Yeah, so this is our small a right here. So that's opposite to our angle that we labeled A. 3.5 is our side B, right? And then 3 would be our side C because it's opposite to our angle C, all right? So we can look through the information that we have now to see how we can go about. We have to find all the sides and all the angles. So we need to find side A, and we need to find angles B and angles C. So when I look at this, if I'm going to use the sine rule to find anything, I need to have at least, because remember the sine rule is A over sine A and equals to B over sine B, right? And A and B can be any side and any angle. What it means is that I need to have at least 3 of these things. I need at least 2 of the sides and one of the 2 of the angles, sorry, and one of the side, or I need 2 of the side and 1 angle that is opposite, right? And I can find opposite angles. So let us look and see what we can find. We don't have 2 angles, but we have 2 sides. So we can use, let me see, B opposite that and A. So we can't use the sine rule because as you can see here, we have a side B, but we don't know angle B. So we would have so if we were to use that, we wouldn't have anything. So this would be an unknown, right? Side B would be an unknown. And we have angle A, but side A, we don't know that. So side A would also be an unknown. And we can't have a formula with 2 unknowns in it. And it will be the same thing if we try using side C and angle C, because one of them is an unknown. So by just doing that and working through it, we can see that we can't use the sine rule, right? Because we don't have enough information to plug into the sine rule formula, right? So then we can attempt now to see if we can use the cosine rule. So the cosine rule, we need to make sure we have one, so it's a squared equals to b squared plus c squared minus 2 bc times cosine A. So if we look, we need to make sure if we're going to use this formula, what we need to make sure that we have 2 sides that we can use. So as you can see, we have 2 sides here. So we can call this B and this C is 3.5 and 3. So we have that. And we have an angle, which is A. So this angle is A here, which means that we can find out this, using this formula, we can find out this side, which is A. So I don't know if you understood what I did just now. All I did was just to go through, and this is how you are going to have to go through. You have to go through and work out what you can find, what information you have, what you can use. So I tried the sine rule, it couldn't work, and then I have to try the cosine rule now, and I realized I can use the cosine rule because I have 2 sides, I have an angle, and the opposite angle is missing, and the opposite side is missing, so I can find the opposite side, as you can see here. So let's put this information into the formula and go from there. So a squared, A is what we're trying to find. So we can just keep a squared equal b squared, which is 3.5. So we can have 3.5 squared plus c squared, which is 3 squared minus 2 times b, which is 3.5, times the c, which is 3, times cosine of a. The angle A is 60. So we can put 60 right there. Everybody is following me so far?
Yes, miss.
All right. So let's go now. Let's do some math. 3.5 squared, you need a calculator. 3.5 squared would give you what?
It gives you
Huh?
12.29. 12.25.
12.25. All right, good. 3 squared gives you 9 minus 2 times 3.5 times 3. So we'll
Gives
just
you
plug this in
21.
the calculator. Huh?
21.
21.
21.
So it's minus 21 times cosine 60. So then we can go ahead. What we're going to need to do now is we need to add this portion and then multiply this portion, right? So 12.25 plus 9, if you plug
21.25.
21.25 minus 21 times cosine 60,
10.5.
10.5, right? So this is just plugging into your calculator. So if
Equals
we
to
subtract this, what do you get?
10.75.
10.75. So we have a squared here, but we want a. So to get rid of the squared, we would have to put
Zero
it
point
under a square root sign. And anything you do to one side, you have to go again and do it to the other side, right? So you will get your answer A equals to
3.27.
3.27 or 3.28, whichever you get. So we've now worked out that A, this side, is 3.27 based on the cosine rule. So because that triangle look a little confusing, I'm just going to draw it back and just put in the information that we just got, right? So we use the 60. Yes. We said that this was 3. That was 3.5. We didn't know what that angle was, nor did we know what this angle was. This was angle A. This was angle C. That was angle B. And we just found the side A to be 3.2 0.27, right? So I just drew back this triangle just because it's a little less confusing than the one at the top right up here, right? So this is now, we found 3.27 to be angle, to be side A. But the question asks us to find all the unknown angles and all the unknown sides, right? So we can now try to figure out if we can find another angle. So we have all the sides, so we can try to find another of the angles, right? So we can use either cosine rule or sine rule to find another one of the angles of the side. I used both and got a similar answer. They weren't exactly the same. They were a little couple decimal places off, but I'm going to just do it both ways to show you, right? I'm going to use the cosine rule as well as the sine rule to find any of these other angles. I'm going to just work it for one of them, all right? So let's go. I'm just going to let me get rid of everything. Now, if you're in your exam doing a question like this is a conversation you're going to have with yourself. Now, once you find this side over here, you're going to have to ask yourself, how can I go about now finding either of these angles right here? No, you have to go through the process again of saying the sine rule says sine A over sine A. Let me just write it. You have to say the sine rule says A over sine A equals to B over sine B. Now, Now, you can ask yourself the question, do I have enough information to solve one of these? To solve B, for example, I have A, the angle, I have A, the side, so this would be okay. I don't have B, the angle, but I have B, the side. So that means you can use the cosine rule, the sine rule here. So we're going to use the sine rule to solve it, and then we're going to use the cosine rule to solve it, because you can use either of them. Everybody following me?
Yes, miss.
So when you come out to exam now on a question like this, and you ask your friend, oh, you find, angle B. Some of them might say sine rule, some might say cosine rule, and then you go and go home and start fret. But the truth is, both of you will be right, because you have enough information to use either of them. So let's start by using the sine rule. All right. So angle A, well, side A is 3.27. So we have 3.27 over the sine of angle A, which is 60, equals to B, side B, which is 3.5, over the sine of angle B, which is what you're trying to find out. Yes? So we can go again. Cross multiply as usual, and I like to have my unknown on my left side because that is familiar, even though it doesn't matter, but I like to keep it at a familiar place when I can. So sine B times 3.27 equals to sine 60 times 3.5. So I'm going to carry over my 3.27. Sine B is equal to sine 60 times 3.5 over 3.27. So this is calculator work now. So let's just put that in. Sine B is equal to sine 60. Let me just work it out. I haven't worked this one out as yet, so I'm doing it with you. Sine 60 is 0.866. Everybody got that? Sine 60?
Yes.
All right, and multiply that by 3.5, which is 3.03, and then divide that by 3.27. You get 0.0092. That's what you got, Shauna?
Oh, hold on.
Do it again. Sine 60 times 3.5 divided by 3.27.
4.926.
Yes, 0.92693 something, but I'll leave it there. All right. And then now you need to get the angle by itself. So it's B is equal to the sine inverse of 0.9269, which is equal to, what did you get?
67.95.
67?
Yes, 0.956 or
Yes.
67.9.
9269. 67.96. I'm going to just run it off 2 decimal places. 67.96. So this is what we get for our angle B right here using the sine rule, right? Sine rule tends to be very, probably the easier one. So persons tend to use the sine rule if they can more than the cosine rule. But we're here in the learning stages of things. So we are trying not to have a preference. So we're going to go ahead and use the cosine rule, or try to use a cosine rule to find the answer to this question as well. So I'm going to erase this if you are finished.
1 minute, miss. One sec.
All right, I'm going to erase it, and then we're going to use the cosine rule to solve this same angle B. So the answer would be similar, but not exactly the same. All right. But both answers would be correct. So any questions so far? I know it's a lot of work, you know. We did the groundwork for this in the previous class. So if you're having a challenge, I would suggest go back to the previous class. We did all the groundwork for it. So today is just about working the questions, getting ourselves comfortable, and being able to approach exam type questions, because exam type questions may not necessarily come well. It is unlikely that exam type questions will come as simple as a single triangle like this. And so we're just getting comfortable with using the formulae, the rules, learning how to, you know, engage the rules and manipulate the formulae to, you know, depending on whether you're finding a side or you're finding an angle. Try and figure out when to use it and when not to use it, and then we will step toward an exam type question. All right, so that's the aim of this, and I'm intentionally going a little slower than usual just to make sure that you are clear on everything. But just bear in mind that these things you're not going to get them after leaving this class today fully. It's not going to embed fully in your brain until you leave this class. What I want is for you to go get some textbooks with some questions, attempt them, work them, and then when we come back Monday, you know, because you would have worked some questions and you maybe buck up on some stuff where, you know, you never understand or you couldn't get a correct answer or whatever the case is, you can ask and you can say, Miss or Sir, this is a question. I couldn't quite do it. Help me to do it, and we will help you through. But you will need to do a lot of work on your own, in your own time. And I can't stress that enough. For maths, practice really and truly makes perfect. And so you're going to have to, especially coming this close to your exam, you're really going to have to start practicing. You should practice your math at least 1 hour per day. Just sit down and work some questions at least 1 hour per day. All right. So let's start trying to use a cosine rule. So this is angle B. So we're going to write the cosine rule in relation to side B, because the cosine rule has a side at the front, right? So this is side B because this is angle B. So this would be side A up here, and this would be side C because of where the angles are positioned, right? So we just found, what did we find? Side C. All right. So we can go ahead now and write the cosine rule in relation to that angle. So B squared is going to equal to A squared plus C squared. I just had a moment. I was trying to figure something out on the triangle. Minus 2AC times cosine of B. Everybody following so far? So if we look at it now, B is the side. We have the side. A, we have side A. Do we have side C? Yes, side C is 3. And we're looking for angle B, which is out here. So because we only have one unknown in the formula, we can always work our way to the formula. Now, there are 2 ways to approach this. You can substitute your values in the formula here, and then you rearrange your formula as you go along, or you can rearrange your formula from now. All all right? I am going to just substitute first and then rearrange afterwards, all right? So let's go. B is 3.5. So it's 3.5 squared equals to A squared. A is 3.27 squared plus C, which is 3 squared minus 2 times 3.27 times C, which is 3 multiplied by cosine B. All right. So that is where we are now. Calculator work. What's 3.5 squared?
12.25.
So that again?
12.25.
12.25, yes. 3.27 square?
10.69.
10.69
Yes.
plus 9 minus, so multiply these now. 2 times 3.27 times 3,
19.62.
19.62. Yes, I got that as well. 19.62 times cosine B. So let us just simplify this a little bit. So this would give you 19.69 minus 19.62 times cosine B. So all I did was just add 10.69 and 9. So now we can start rearranging our formula to make cosine B the subject. So the first thing we're going to move this
10.69.
16.9 go over. So we're going to end up with, because it's being added here, it's going to be subtracted over there. So we're going to end up with 12.5 minus 19.69 equals minus 19.62 times cosine B. If you want, you can work this out. I'm not going to work it out as yet. I'm going to just do my second move first, which is to move this across the equal sign. Now, because it is being multiplied here, when I take it across, it's going to be divided. So I'm going to have 12.5 minus 19.69 divided by minus 19.62 equals to
Miss,
cosine B. Yes.
question. When you bring over that negative, should it be a positive or
It,
remains a negative?
no, it can be a positive. So the value of it doesn't change. So the value is a negative. This negative sign here is not a subtract. It relates to the value, meaning that it is gone 19.62 times across the equal sign, across the zero, past zero in the left direction. What you're concerned about is how it is being operated on over here. So over here, it's being multiplied, and so that's what changed when you take it across, not the sign.
Okay.
So if you think about when you carry a number, just a regular number, if you carry 3 across the equal sign, when you go over there, it don't turn -3. If you divide it by it don't turn negative. It just, you divide by 3 because the value doesn't change. Yeah. Clear?
Yes, miss.
Great. So let's work this out now. The top part is going to give you, should be a negative number, I think.
Negative 7.19.
Okay, 12.5 minus 19.69, negative 7.19, and then you're going to divide that by negative 19.62.
Gives you
And your answer.
0.36.
Hmm?
You will get 0.366.
Yes, 0.3668 equals to cosine B. So again, you now have to think about moving this cosine B so you can get the B by itself. So that will leave you in a position with
Inverse.
cosine inverse 0.3668 equals to B. And do I have any more space? If you plug that in your calculator,
68.48.
68.
0.48 degrees.
All right, what do we get when we use the sine rule?
Use the sine rule, got 67.9.
Right. So as I said, it will be close, but it won't be the same. But if you use either of these, your answer should be correct within a degree or so of each other. And I won't go into the reason why it's not going to be exactly the same. But as you can see, it is within a degree. I think it's less than a degree, but it's fine, right? So if you decided to use the cosine rule to solve, you would be perfectly correct. And if you decided to use the sine rule to solve, you would also be perfectly correct because the information is there to support using either of them. All right. All right. So I'm just going to now redraw this triangle again to put in the information that we just got. I don't want to have one triangle looking too crowded. So A is 60. C, we still don't know. We haven't found that yet. B, though, we just found to be 60. I just using this answer, 68.48. Um, all right, so this is what our new triangle looks like. So we only have one thing left to find. So we only have one thing left to find, which is angle C. How do you propose we go about finding angle C? Easy, easy, easy. You don't
Add
even
both angles. Add both angles and then subtract it from 180 degrees.
excellent. So again, some persons may not see that, as simple as it is. Some persons, because they're under exam, they might think that, boy, this is too simple and I can't away there. And they might decide to use the sine rule or cosine rule, and you will be perfectly okay using it. You should get the same answer. So for practice, you can use the sine rule or cosine rule to solve it. But the easiest way is angles in a triangle
So 180.
equals to 180 degrees. 180 degrees. And so the missing angle must equal to 180 minus the two angles that you have, which is 60 plus 68.48.
128.48.
Hmm?
180 minus 128.48
And then the answer
equals
will be
to 51.5.
5-1.
52. 51. 51 in a minute, not 52.
51 point what you say? 0.22.
52.
Okay, 51.
51.5.
0.52 degrees. And so we would have answered the question by finding all the angles and all. And remember, we started out with this triangle up here where we only had two sides and one angle. And now we have all the sides and all the angles by using the sine rule, the cosine rule, and the rule of the sum of the angles in a triangle. Any question? I know it is long, and all of these things, but these things happen, yes? And these, you remember that it's 6 years studying for, so, these are the questions that you're going to have to face. The good thing is,
Which is there a shorter way?
short away to do what? This
Noodle
question,
padlet.
no, no,
Yes.
no, don't exist. That I don't know if it exists. You just have to use the.
Long.
It's not long. Well, I mean, you're finding one angle. Well, you're finding one side and two angles. So you're solving for three different things. So it's going to take you some time. It's going to take you some time. But just believe me, when you start practicing, so over the week, when you're doing all of these questions in number 7, and you're thinking about it, it becomes that much more easier. You're not going to get it easy the first time of asking, and that is completely fine. However, the more you work, is the more you will get. You will flex your muscle, and it becomes easier for you to appreciate the stuff. So don't worry about long and short. Exam have 2 hour annual, 2 and 2.25 hours, so you have enough time to do your work because that is what it takes to do it. So you just have to do it in at the time. So you don't worry about the time. Just make sure say you're able to do the work. Yes?
Okay.
Yeah, we don't worry about question or exam and set. We worry about just making sure that we can cover the content, right? Once you're able to do that, you just go to exam with a full belly, fully rested, and you come prepared for anything that an examiner decides to throw at you. All right, so we're going to do one last question and it will take us up to 12 o'clock. I am sure, well, I'm not sure, but it should take us up to 12 o'clock. One last question to try and draw this triangle. And I'm going to give you some time to think about it, just to think about the question itself and give you about 5 minutes or so to come up with some ways that you can work it, and then we will attempt working it together. I want to give you the time to try and figure it out. Use the time to try and figure it out, because when you're in an exam, I'm not going to be there to come at the end of 5 minutes and tell you how it works, right? I want to know what is going on in your mind so I can help you to, re-gauge your thoughts. But you also need to exercise your brain muscle. Exercise it by thinking about the question, because that is what you're going to have to do in your exam. So don't be lazy and depend on me and say, Mr. I'll come work it anyway, so let me wait for an hour. No, please think about the question and come up with some ways that you can possibly work it out. All right, so this is our question. Okay. That never records that. All right. All right, so this is your triangle that you're going to be working with, and it's a triangle with triangles. So You are given two angles. One is 34, one is 42. And you're also told that AD, which is this, AD is equal to AC, which is this, and the size is 10 centimeters. So if you want, you can put 10 centimeter here for this length, A to C, and 10 centimeter for A to D. But the question gave it like this, I suspect, because they don't want to crowd up the triangle, right? So bear this in mind. A to D and A to C are equal lengths, and they're both 10 centimeters. So you're being asked to find angle ADC, which is ADC. So you're being asked to find this angle here. Let me just put it in a different color for you. Angle ADC. So this is A, B, and C is there. So you're asked to find this angle. This is ABC. And then you're being asked to find BAC. So BAC, which is this angle here, right? So that's what you're asked to find in terms of angles. And then you're being asked to find the length of AB to three significant figures. Then you're being asked to find this length here, AB, to three significant figures. So I'm going to give you 5 minutes just to play around and think about how you can go about finding any of these. Well, you have to start with AD before you can find this and that, but try to figure out how you can find it. When we come back, we will have a discussion first, because I want to hear how you thought about it. That's important first step, and then we will work it out. So 5 minutes.